Um, Welcome everybody to today's webinar. My name is Davis Gimode, and I'll be walking us through our lesson for today. I'll be helped by Saber and Abby, and also Jason is here, and he'll also be my helper today. So we're going to get started, and we'll start by looking at the homework that Jason sent out last week. It's involved working with a Gapminder dataset, and assuming that everybody has that downloaded, and in case you've not, I can put the link in the chat box, and you can. I think I've sent that privately. Let me just send this to everyone. Yes, I've put the link again to the Gapminder dataset on the chat box, and in case you had not downloaded that, you can go ahead and download it, and we'll go through the questions that were asked. So as usual, the first thing to do when you want to start working is to set up your working environment to the right directory. And you usually do that by going to session, then you say set working directory, and then to choose your directory. In my case, I'm working from the desktop, so I'll select desktop and my preferred folder for working. And the command is also displayed down. You can use this if you prefer to enter the command set wd, and then you put the path to where the directory is. And then once you do that, the next thing is to load in the dataset, to read in the dataset. And I'll read it in, and I'll put it in a variable that I call Gapminder, and say equals to, and then read.csv, and then I'll put the name of the dataset. That's Gapminder underscore data.csv. And if I say Control Enter, the dataset is read into my RStudio environment. And then we can go through the questions that were asked. So we've loaded the data into R. The first questions were how many rows of data are there, and then how many columns, and what is the data type of each column. And basically this involves the preliminary exploration of the data, and it's something that's very important to do whenever you receive a data set. And based on the commands that we learned last time, if you want to look at the number of rows, you can just come and say n row, and then you put the name of the variable that has the data frame, and that's Gapminder. And if you say Control Enter, at the terminal, you can see it shows us that we have 1,704 rows. To look at the number of columns, you can simply come and say ncol, and then again say Gapminder. You say Control Enter, and it tells us that we have 6 columns in that data set. And then very conveniently, if you prefer, you can use one command for those two, and that is dim, and put in the name of the data set, Gapminder, Control Enter, and it shows you 2 numbers, and the first one is usually the rows, the number of rows, and the second one, the number of columns. So that's also a convenient way to check that. And then in order to know the type of data in each column, you can use the command str, and then put Gapminder, and then Control Enter. And when you do that, it lists the columns on the left, and then you can be able to see after the full colon, you have the kinds of data that is there. So you have the country is a character, and then integer for the year, the population is numeric, character, numeric, and numeric for life expectancy and GDP per capita. So what I'd do personally is if I'm interested in a particular column, what you can do is actually pass that specific column to str, and you do that by coming and mentioning the entire data frame, and then use the $sign to specify the column that you're interested in. So for example, if you want to know the kind of data in the country column, you just use the $sign and then specify country. When you do that, you see that it shows you specifically that the country column has a character as the kind of data. So the other question that we had was print out the last 20 rows of data. And in order to show the last set of rows of a data set, you use the command tail. And then you open and close brackets and then put in the data frame. If you just leave it at that and say enter, it will show just 6 rows. But if you're interested in showing a specific number of rows, you put a comma, and then the second thing you put is the number of columns, the number of rows that you're interested in. So in this case, it's 20, so I'll say n is equals to 20. And if I say that, indeed, I get a longer list of rows that are shown, and in this case, 20. And also worth noting, this came up last time, you actually do not need to say n equals to 20. If you just put the number 20 and enter, it will still show you the same thing, because this function, the tail function, expects the second option that you put in to be the number of rows that you're interested in. At the same time, if you want to look at the top of the data set, you can use the head command. And if you say gapminder, if you say enter, it shows you the first 6 rows. And then again, if you want to see a specific number, say 20, if you say control enter, it shows you the top 20 rows that you requested. And then the next question was to make a new data frame that contains just the data for 1952 and another that contains just the data for 2007. And then what is the median global life expectancy in each year? So this is an exercise about subsetting the data, similar to how we learned last week. And how I'd approach it is to create a variable for the year 1952, and I'll call mine Y52. And then to this, I'll come and get the entire data frame. So gapminder is the entire data frame that I want, but I don't want everything there. I only want a subset of the data. So I can use this open and close square brackets. And when I give that to R, it shows it that I want to actually take a subset. So inside these square brackets, what you need to have is a separation between the rows and a specification for the rows and the column. And these are usually separated by a comma. So if you put a comma there, on the left side of the comma, you have the specifications for the rows of interest. And on the right, you have the specifications for the columns of interest. So in this case, I want all columns. So I will not do anything. I'll not add anything else on the right of that comma. However, for the number of rows, I only want rows for which the year column is 1952. So here I'll specify by mentioning the entire data frame gapminder, and then I'll use, there's many ways, several ways to do this, but the simplest I think is to use the $sign to specify a column of interest. And in this case, I'm interested in characteristics in the year column. And then if I select that, I can come and use the double equal sign to say that I want this to be 1952. And then I come and say control enter. If I do that, if I do a head command on that, on the subset of the data frame that I've created, Y52, and then I say control enter, I can see that on the year column, everything is 1952. So similarly, to get data for 2007, I'll just use the same method, but in this case, it's easiest for me to just copy this, paste it here, and then I'll say year 2007. Again, it's gapminder, and then on the year column, I want it to be 2007. So I change that to 2007. I'll say enter, and if I use the head command to look at the top of the subset, if I say enter, I can see that on the column, on the year column, I have only data for 2007. So an alternative way that you can get this, the same information, is to use the subset command. And And the subset command, I don't know, it might be simpler to use it, as the syntax is very simple. We just have the open and close brackets, and then it expects as the first criteria you give it is the data set, the entire data set. In this case, it's Gapminder. Sorry for this. Gapminder. And then comma, and then after the comma, the second conditions that you give it is the characteristics of the row that you're interested in. And in this case, it's where the year is, for example, 1952. 1952. It can take a second, it can take a third options after the comma where you specify specific columns that you're interested in. But since you're not interested in subsetting the columns, you want all the columns, you can leave that blank. And then we can put this in a variable. So I can say y52 2 equals to subset Gapminder, year is 1952. If I say Control Enter, and then I do ahead of this, y52, the second one, and then Control Enter, I can see that it also gives me a subset of the data such that the year column is 1952. So as usual, there is several ways that you can do things, and subset is an alternative way to do that. And then the other question was, what is the median global life expectancy in each year? So one way to do that, a command that we learned last time, was to use summary. So summary, if you say summary and then you look at y52, Control Enter, it will give you a summary of every column in the data set. And if you look at the life expectancy, just get that. The life expectancy is here, and if you look at the median, is 45.14. And if you do the same for the year 2007, you get the same summary of the columns, and for life expectancy, you see it's 71.94. However, for me, I think the best way, the cleanest way for me to do it is to use the median command, which will directly calculate, which will directly give me the median of what I'm interested in. So in this case, I'll come and say for year 52, and then I want specifically the column on life expectancy. So I come and say life expectancy, I say Control Enter, and it gives me the exact same value as the summary, only that here it's much cleaner and I don't have to sift through all the stuff that R prints out. Similarly, for the 2007 subset, I can come and say Y07, and then for the column, I specify that I want the life expectancy, and then Control Enter, and it gives me the very exact data that I've asked it to. And then finally, the last question was in 2007, how does the median income, that is the GDP per capita, and life expectancy of Africa compare to Europe? So for me, what I'd do is I'd take a further subset of the 2007 data, and I subset that by continent for either Africa, for both Africa and Europe. And I'd come and say, so for year 07, I come and say Africa, I call this Africa. So I'll put that in this variable, and then I'd subset the year 07. And then I'd prefer to use the subsetting using the square brackets. So I'll come and say 07, and I want the continent. So I come and specify continent here, where the value of continent is Africa. And that gives me the specifications for the rows. And then I come and put a comma and leave the right of the comma, which specifies the columns that I want blank, because I want everything. And I'll say Control Enter. And if I do ahead of this and say Y07, I can see that it gives me on the continent column, it's Africa, and from the year it's 2007. And you can do the same for Europe. And in this case, I just come and copy and paste that here, change the variable to Europe, and then specify that the continent I want to look at is Europe. I'll do a control enter there, and then I'll come and say Europe. And so that enables me to subset that for Europe as well. And then you can look at the medians using the command, the median command, and I'll come and say the median, I want year 07, Africa. And then I want, so for the year 07, Africa, I want to look at the GDP per capita. And I say control enter. And that gives me the value of the GDP per capita for Africa. And I can do the same for Europe. In this case, I'll come and change this to Europe. And straight away, I have the values for the medians for both Africa and Europe that I can compare. And you can do the same for the life expectancy as well. So in this case, I'll come here and say the column I'm interested in is life expectancy. I say control enter, it gives me the value for Africa, and I can copy this, paste here, and I'll come and specify that I want the life expectancy for Europe as well. And straight away, I have the medians for the GDP per capita and the life expectancy for both Europe and Africa that you can compare for the year 2007. So I think that's what the homework was all about. And yeah, I don't know if anyone has a question, you can feel free to put it on the chat box. And if not, we can proceed with today's lesson. So today we want to learn about conditions, and this is a way in which these are methods that you can use to control the flow of actions in R. So specifically, I want us to learn about two specific types of conditions. We have the if statements, and also we'll learn about the else statements. So to begin with, I think I'll give us the syntax for these two statements, these conditional statements. And the syntax is actually pretty simple. We simply come and we say if, and then this is followed by open and close brackets, and then you put a condition of interest that you're interested in, which will be evaluated, condition to be evaluated. And then once that condition is evaluated, there is an action that is performed. And then once the action is performed, and my apologies. So after the evaluation of the condition, you'll have an open curly bracket. Sorry for this. And then an action to be performed, and then you can close the curly bracket. So that's the basic syntax of the if statement. And I'll give an example to illustrate this in a moment. So, but it's more useful to follow the if statement with an else statement. So in this case, you take the if statement, and I'll just copy the if statement here and paste it down here. And we can extend this by using the else. In this case, what I want the else to do is to have this condition that you've put evaluated, an action is performed, but what if the condition that was evaluated is false? So that's what the else statement does. So you follow this with an open curly bracket, and the else statement essentially just tells R what if this condition, the condition that you put, is false. So if that's the case, then it will tell R to perform an alternative action. And the best way to understand how this works is to use a practical example. So let's create a new variable, and we can call that X. And we assign the value 8 to X. So if I say Control Enter, I know that X is 8. So what I can do is come and use the if statement to do an evaluation of this. I'll come and say if, and then as the syntax suggests, you have an open and close bracket, and then I say X is greater than or equals to 10. That's the condition that I want to be evaluated by R. So once it's evaluated that, I'll have an open and close curly bracket. Within that, I'm going to ask R to perform a particular action. In this case, I want R to print a statement. So I'll use the print command, and then I'll come and say that X is greater than or equal to 10. So if the if statement will come and have X evaluated for whether it's greater than or equal to 10. But if this is true, this statement that X is greater than or equal to 10 will be printed out. If I run this command by, say, Control Enter, nothing happens, simply because this statement is not true. So if I want to see an alternative that I want R to do if this statement is not true, that's when I use else. So I'll copy this command here, paste it here, but now I'm going to extend it with an else statement. So I'll come and say else. So if X is greater than or equals to 10, print that, or else I want you to do something different. So again, I'll have an open curly braces, and then within that, I'm going to say print, and then I'll come and put the statement that X is less than 10. So in this case, if I run this command and say Control Enter, if the if statement evaluates whether X is greater than or equals to 10, and it finds that it's not true, so this condition is not met, therefore this action is not performed. However, the alternative action is performed because the condition requires the alternative actions to be performed. In this case, it is to print out that X is less than 10. So to test whether this is clear, I think I'll give out a practical exercise that all of us can do to check if we've understood the syntax for that. So this is what we can do. I want us to assign the number 8 to a variable other than X. So here we assigned 8 to X, but I want you to assign it to another variable that is not X. And then test if the variable is not equal to X. So we previously assigned X. And then if the condition is true, I want you to print the variables are different. And if the condition is not true, print the variables are the same. And I'll give us maybe 2 minutes to do this. And when you're done, you can type done on the chat box. Okay, I think about half of us are done. Maybe I can give us 1 more minute. Okay, I think we can proceed. I'm going to show how to do it, and I can see that someone has said that Zoom is not stable on their end. I don't know, is it okay with everybody else? Or it could just be an internet connection problem, probably. All right, so probably it's just an internet connection problem. I'm sorry about that. So I'm going to show how I'd approach this question. So I'll come, we said we need to assign the 8 to another variable. For me, I choose the variable y, and I'll say y is equals to 8. And then at least the if statement to come and say if, and then again, the syntax indicates that you need to open and close bracket. And then I'll come and say why. In order to show that something is not equals, we need to put the exclamation mark and then the equal sign. So this means that y is not equals, and then say x. So y is not equals to x. And that's the condition that I want to be evaluated. And then open curly braces. And then the condition that I want to, the action that I want to be done is to have a printout. So I'll say print and say the variables are different. However, if it so happens that this condition is not true, I want something else to be done. So I'd extend that with an else statement and then use the curly braces and then perform a different action. And in this case, my alternative action is to print that the variables are the same. So if I run this, I'm going to run the first one, y equals to 8, and then run the conditional statements that I've put in. If I do that, so the first action that I wanted is not printed simply because y, since y is 8, it is not equals to, since y is 8, it is the same as x. So the variables are not the same. Therefore, the second action is printed out. So the other thing that the conditional statements that can be done using conditional statement is to extend this. Instead of just using the else on its own, we can add another conditional statement called else if. So we can also use the else if to enable us to extend this conditional statement to test multiple actions, multiple conditions that we want. So how we do this, we'd still use the same variable that we created x. And this is an example that I'm giving. We can use the same variable that we created x and we assign that to 8. And then I'll come and say if, and then based on the syntax, open and close the bracket. And we can try to test and see if x is greater than or equals to 10. So that's the condition that I want to be evaluated. So if that happens to be the case, I want R to print. This is the action that I want, is for R to print x is greater than or equal to 10. So that's the action that I want printed out if the first condition is true. However, if the condition is not true, I'm wondering whether we can extend this by putting another condition. So in this case, we'd use the else if statement. So I'll come and say else if, and then I'll put a second condition that I want to be evaluated. So I'll use an open and close bracket, and therein I'll put x is greater than 5. So I also want that to be tested, whether x is greater than 5. And if that's the case, the action that I want is for R to print something out. So I use a print command and say x is greater than 5, but less than 10. So that's the action for the second condition of interest. However, if all these fail, if all of these are false, So I'll use the else command that we used earlier, and I'll ask R to do another action, an alternate action to the conditions that we put earlier. So I'd say I want R to print out that X is less than 5. So if I run this, we see that the condition, the action that is printed out is a second one. So the first action, the first condition is evaluated. X is greater than or equals to 10. Of course, we know that's false. So the first action is not taken. However, it evaluates the second action. So it says X is greater than 5. And that's true. Since X is 8, we know it's greater than 5. So the second action is printed out, that X is greater than 5, but less than 10. And then the alternate is X is less than 5. So we don't get to the alternate action simply because the second condition was met. So what I want to emphasize here is that when you use the conditional statements, the if statement, R evaluates the conditional statements and looks for logical true or false statements. So R is evaluating by looking for logical true or false statements. So for instance, inside this bracket, we see X is greater than or equal to 10. If I isolate that and just print it out, X, we know X is 8. But if I come here and say X is greater than or equals to 10, if I run that just on its own, you see it's false. So the condition that we put here, that X is greater than 10, is evaluated as false. And you can test for multiple conditions that you can envision to put in there. For example, you can ask, is X, for example, you can say X is equals to 10. If you run that, it's false. If you say X is less than 10, if you run that, that's true. So X, if you say X is less than or equal to 10, and you run that, that's also true. And definitely, if we say that X is equals to 8, and we run that, that's also true. So just, I'm showing this just to show that the conditional statements are telling R to evaluate logical statements that are either true or false. And if it's true, something happens, and if it's false, an alternative thing happens. So right now, I'd like us to do a second exercise. And I'm going to paste it here. So I want us to use an if statement to print a suitable message. Let me just format this. Reporting whether there are any records from the, okay, so here we need to use the gapminder dataset. So the gapminder dataset that we loaded in, we want us to use the if statement to print out a suitable message reporting whether there are any records from 2002. And the tip here is that you might require to use the previous knowledge on subsetting that we learned in the previous lesson and that we've also gone through in the homework. So I'll give us 2 minutes to do that. And when you're done, please type done on the chat box. Oh, okay, so I can see Naomi said you said, what does this mean? In if Gapminder year is 2002, the condition has length is greater than 1 and only the first element will be used. Not certain. I've not seen that yet. Probably. Yeah, probably we might be able to see why that happened as we look at the example together. Okay, so I think we can proceed. And so let's see. This is how I'd do it. What you want to do if for example, you do a head on Gapminder. what I want to do is to have an evaluation of the year column and see whether there's an occurrence of 2002 therein. So, and here I'd say, you remember how we subset the data and previously. So for example, for us to get, when we subset the data and we wanted to get a data frame that is a subset of the whole, if we wanted to do it by year, you'd put a command such as this, gapminder, and then for me, I prefer subsetting using the curly, the square brackets. And then I'd come and say gapminder, and then I want the year column. And then for the year column, what I want to see is if there is 2002 data there. And then I want, I can mention that I want all the columns. So this is how we previously subset the data. However, I really don't want to get a new data frame with the year 2002. So one way to look at this is to check whether, if you take a subset of this data, whether we can be able to get rows that have 2002. So if we use the command that we learned last time for number of rows, and we apply it to the subset of this, to this subset, to a data that has been subset in this manner, what we know that is if 2002 exists and we run this, we should be able to see a value, and that value should be at least, if there's any data there, there should be at least one value, one row. There should be at least one row that has the data on the year 2002. So if you think about it that way, what we know is we can be able to put this statement into a logical, into a further logical statement. So for example, if 2002 exists, we know that we have to have at least the value of 1 when we count the number of rows in that subset. So if I come here and put and say it's greater than or equals to 1, so straight away this evaluates into a logical statement. So if I run this, we have true or false. So after that, once we have this, once we have a statement that can evaluate to true or false, it is possible to put this into an if statement, and then have that evaluated. For example, we can come and say if, and then open and close bracket, and then we can take this entire statement that we've created, which will evaluate, which is supposed to be evaluated to either true or false, and then we can come and say we want a particular action to be done, and in this case we want it to print out that the data for 2002 exists. And if we run this, the action is actually done. So at this point, probably you can look at what Naomi said. She said that, let me just read, that what does it mean if gapminder, the year is when you get this message that the gapminder year is 2002, the condition has length 1. So the thing is, I think you use an if statement to do that. And so the message means that the if statement will only take a single true or false answer, not a vector, unlike, for example, when you use subsets. So I think if you use the if statement, that's when you get that error. However, the thing is, sometimes you can get a warning and it works, but it's usually good to not just proceed because it worked, even though you got a warning. It's better to troubleshoot and find out exactly why did it work despite having a warning.
Davis, I have a comment about this question.
Sure, go
I
ahead.
think the question says that in the question it says if gap $year equals to something, but in your example it is number of rows. So you should check number of rows to see if they are more than one or not, because this way that you're writing if gap on the $year equals to something, it applies to more than one row, and you cannot use a condition in an if statement that applies to more than one row.
Okay.
So yeah, in the question that Regan and Namia are asking, I think they should use gap here.
Oh, that's right.
row.
Yes. Yeah. Yeah, and I can see that also on Riga's answer. So yes, when you use the number of rows, it gives you it gives you a single logical statement, true or false. But if you just use gap $year, it actually prints out it actually prints out a list of things that we're going to be evaluated, and so that will not work. And I'm just yeah, and I think this is what I'm just going to paste what Regan put. I think Regan, this is what you put out. You said if gap year is 2002, print there is no data. Okay, so your data set is Gapminder. And then, so the thing is, if we take this and probably run it, it creates a whole set of true and false statements. So as opposed to, as Saber has said, using just the end row, because when you use the end row, for example, as I did here, it actually gives me just one single true or false statement, and that is able to work better. Yeah, so that's right. So Naomi, that's right. You want that the point of evaluation, you want to evaluate just one condition, one true or false statement. All right, so we can look at another way to do this, and we can use the any statement. So you can also use any to achieve the same result. So you can come and say if, and then you come and say any. And then what you give to any is the data frame. And then you specify the column that you want, which is year. And then for the year, you want this to be 2002. And then if that's the case, the action that we wanted was to print data for 2002 exists. And if we do this, this works. This works because, and I think this is actually closer to what Regan you're doing, only that now we've used the function any, and when you give any and you give the year column to any, what any does is that it looks at the entire vector. It looks at the whole vector of the column of the column year, and then it evaluates and it takes at least, you want to have at least one occurrence. And then if there is at least one occurrence, the action the action that you requested is done. So probably if you want to use the same syntax similar to what Regan you had put, you can use any command. I think that will work as well. So I want us to do one last exercise. And I'm going to paste it here. Oh, sorry. Let me copy it and paste it again. Copy. So I want us to, I'm going to format this a bit. So what I want us to do is to use an if statement to report whether there are any records from 2012 and an else if statement to check if there is data for 1992 and print an appropriate message. So essentially, I want us to use an else if to put multiple conditions to what we've done. And I'll give us probably 2 minutes to do that. And you can type done when you're done. Okay. So I can see a good number of us are done. If you don't mind, I'm just going to show this. Similar to how we did the previous exercise, we'd take the if statement, and then I'd prefer to use my method of evaluating the number of rows. And then so I'd evaluate that on a subset of the gapminder data set. So I'd put Gapminder, and then Gapminder, and then for the year, I want the year column to be 2012. So I want that evaluated, and 2012, and then yeah, so very important, I want the logical condition to be evaluated. So I'll say greater than or equals to 1, and then I'll use my curly brace, and then if that's the case, I want there to be a printout that data for 2012 exists. So however, we wanted to extend this statement, so we'll use an else if statement. And in this case, just copy and paste again. And then I want it to be 1992, and then I'll use curly brace, and then if this evaluates, what action I want to be done is data for 1992 exists, but not for 2012. But not 2012. And then if all this is false, I want the alternate to be a printout that neither 1992 nor 2012 exists. So if I run this, we see that it evaluates the first condition, and that is checking for 2012. And since the data does not reach 2012, the first action is not printed. However, it evaluates again for 1992. And since 1992 data exists, the second action is printed out, that 1992 exists, but not 2012. And therefore the alternate does not need to be printed out. So, and that is how we use conditional statements, if, else, and else if. And I think this takes us just beyond 2, and we can probably take a pause here and probably field questions.